For centuries, maritime engineering relied on a comforting statistical model, the Gaussian distribution, or the bell curve. This chart maps out average wave heights in a given sea state, showing that if most waves in a storm are 10 feet tall, you might occasionally see a 20-foot wave. But a 100-foot wave? The math places that far out in the thin tail of the curve, in the zone of statistical impossibility. It was considered an extreme anomaly that might only happen once in 10,000 years. Because the math dictated these giants couldn't exist, the scientific community dismissed centuries of logbooks and survivor accounts. Sailors returning to port whispered terrifying stories of sudden, vertical white walls of water that swallowed ships whole and vanished into the dark. Oceanographers sitting in dry offices wrote these reports off as optical illusions, the results of exhaustion, or simply the exaggeration of men trying to explain away their own navigational errors. Trusting the mathematical average had severe consequences. In 1978, the MS München, a massive, state-of-the-art German cargo vessel built to withstand the absolute worst weather the North Atlantic could generate, vanished without a distress call. Searchers eventually found a single empty lifeboat floating in the currents. Forensic analysis of the boat's twisted metal mountings revealed it had been sheared off the ship 66 feet above the waterline. The vessel's superstructure had been pulverized by a solid mass of water at a height the engineering charts deemed perfectly safe. Then, on New Year's Day 1995, a downward-facing laser mounted on the Draupner oil platform in the North Sea recorded a fingerprint. This line graph shows the laser's data. You can see the rhythmic 12-meter waves of a severe winter storm rolling past the sensor. Then the line spikes. A singular vertical mountain of water, reaching 25.6 meters, 84 feet high, erupts out of nowhere, striking the underside of the rig. That laser measurement broke the model. It provided undeniable proof that the ocean is not a polite, linear system. It can cheat probability. And it meant that the entire global shipping infrastructure, every cargo vessel, every aircraft carrier, and every oil rig, had been engineered to survive an ocean that does not actually exist. To figure out how water stands up like a skyscraper, we have to look at what these monsters actually are. A rogue wave is not a tsunami, which is triggered by an earthquake, nor is it a storm surge drawn up by low atmospheric pressure. It is a surface wave, born of the wind, that has somehow mutated entirely into a terrifying, unpredictable phenomenon. This vector graphic illustrates what happens in crossing seas, where entirely different weather systems collide and ocean swells intersect. Under these chaotic conditions, a stable group of waves can lose its coherence. Instead of simply adding their heights together as they cross, the ocean multiplies its energy. A single wave acts like a parasite, draining the kinetic energy from the waves directly in front of and behind it. As this exponential theft occurs, the surrounding waves shrink into mere ripples. The central wave peaks into a highly unstable vertical tower. A rogue wave is a highly concentrated, transient beam of kinetic energy. The ocean acts as an overcharged battery, inhaling the power of its surroundings and discharging it entirely in a single focused burst. Building a crest of that magnitude requires a brutal physical exchange. You cannot build a mountain of water without digging a valley. To reach its towering height, the rogue wave sucks the ocean directly in front of its path dry, excavating a steep, deep trench known to mariners as the Hole. When a vessel encounters this trench, the water beneath the keel vanishes. The ship loses its buoyancy entirely, pitching forward at a sickening 40-degree angle. It stops sailing and starts free-falling down a dark elevator shaft into the trough. At the bottom of that pit, the ship loses its ability to lift its bow, and that is when it meets the wall. Normal storm waves are sloping hills that ships can ride up and over.
A rogue wave is a vertical, collapsing cliff of white water that violently strikes the trapped vessel head-on. Because the wave is so steep, the water hitting the ship isn't airy foam, it is green water, a solid, dense mass of ocean. It slams into the vessel with an impact pressure of nearly 100 tons per square meter. That is a percussive hammer blow 10 times the force of a normal wave. easily enough to snap a tanker's keel or crush a steel hatch inward like aluminum foil. As terrifying as a solitary giant is, there is a rarer, deadlier variation called the Three Sisters. This is a wave packet, 3 synchronous giants traveling together. The first wave knocks the ship onto its side and floods the deck. Before the heavy vessel has time to drain the water and recover its center of gravity, the second and third waves strike, driving the helpless hull completely underwater. The anatomy of a rogue wave forms an inescapable geometric trap. By combining a precipitous pitfall that robs a ship of its maneuverability with a crushing vertical impact, the ocean creates a scenario that standard commercial vessels simply cannot survive. Recognizing this threat, naval architects are abandoning the old averages. We are now designing ships as armored bunkers meant to deflect catastrophic impacts. You can see this evolution clearly in modern cargo vessels, which prioritize defensive altitude over traditional streamlined shapes. Bows are becoming massively flared, specifically angled to shed heavy green water away from the deck before it can pool and crush the ship. The bridge, the vulnerable brain of the vessel, is retreating. Designers are pushing the superstructure further back and much higher up, attempting to place the human crew safely above the reach of the white wall. But passive armor has firm physical limits. In 2001, a 100-foot rogue wave struck the MS Bremen, a luxury cruise ship built with heavy, multi-layered windows tested to withstand immense pressure. The vertical wall of water smashed right through them, flooding the bridge, destroying the navigation systems, and leaving the vessel drifting broadside to the waves without power. Physics will always favor the ocean in a direct collision. No matter how thick the steel, armor is just a hope to take the punch. The ultimate survival strategy is learning to anticipate the wave and dodge the direct impact entirely. To give ships reflexes, scientists are turning to active defense. They are training artificial intelligence neural networks and mounting LiDAR lasers, systems that use light to measure distance, on the bows of ships to read the chaotic, intersecting grid of the ocean in real time. These algorithms scan the water for the subtle, almost invisible precursors of energy clustering. By recognizing the specific geometric patterns that form just seconds before the water cannibalizes its neighbors, the AI can predict a rogue wave's formation, offering crews a crucial 2-minute warning. 2 minutes isn't enough time to outrun the monster, but it is enough time to survive it. It gives the crew time to sound the alarms, seal the watertight doors, and pivot into the swell, ensuring the hull takes the hit on its strongest point rather than its vulnerable flank. However, the playing field is actively changing. Human activity is pumping immense heat into the atmosphere, and the oceans have absorbed over 90% of that excess thermal energy. That trapped heat drives the global winds, intensifying storm systems and increasing average wind speeds across the planet. A rogue wave acts as a multiplier of the background sea state. If the average height of a storm rises even slightly due to this added energy, the rogue wave scales up multiplicatively. The rare 100-year giants that shipbuilders use as their ultimate safety benchmark are rapidly becoming taller, steeper, and significantly more frequent. We can wrap our world in satellites, train artificial intelligence to watch the dark, and weld thicker steel onto our bows. But the rogue wave remains the ultimate equalizer. It is a precise physical reminder that the ocean is a wild, indifferent force, and we are merely guests floating on its surface.